everyone, this is Arjun Shani from Department of Computer Science, Sindh University campus.com to Pick 20 page. Today we discuss four topics of basic electronics. Outline, diode, resistor, resistor and color coding, resistor in series and parallel. First of all, we discuss about diode. What is diode? A semiconductor diode is a two-terminal electronic component with a p-n junction. This is also called as a rectifier. Diode is a semiconductor component. Diode is made from small piece of semiconductor material, usually silicon, in which half is dropped as a p region and half is dropped as an n region with a p-n junction and depletion region in between. Sample of diode. The anode, which is the positive terminal of diode, is represented with A, and the cathode, which is the negative terminal, is represented with K. To know the anode and cathode of practical diode, a fine line is drawn on the diode, which means cathode, while the other end represent anode. Formation of diode. If a p-type and n-type material are bound to close to each other, both of them join to form a junction, as shown in the figure below. A p-type material has holes as the majority carries, and n-type material has electron as the majority carries. As opposite charge attract, a few holes in p-type tend to go to n side, whereas a few electrons n-type tend to go to p side. As this region acts as a barrier between p and n-type materials, this is also called as a barrier junction. This has another name called as a depletion region, meaning it depletes both the regions. There occurs a potential difference Vd due to the formation of ions across the junction, called as a potential barrier, as it prevents further movement of holes and electrons through the junction. Biasing of diode. When a diode or any two-terminal component is connected in the circuit, it has two biased conditions with the given supply. They are forward bias condition and reverse bias condition. Let us know them in detail. Forward bias. When a diode is connected in a circuit with it is anode to the positive terminal and the cathode to the negative terminal of the supply, then such a connection is said to be a forward bias condition. This kind of connection makes the circuit more and more forward bias and helps in more condition. A diode conducts well in forward bias condition. Reverse biased. When a diode is connected in a circuit with it is anode to the negative terminal and cathode to the positive terminal of the supply, then such a connection is said to be a reverse bias condition. This kind of connection makes the circuit more and more reverse bias and helps in minimizing and preventing the contaction. A diode cannot conduct in reverse bias condition. Purpose of diode. A diode is used to block the electronic current flow in one direction, in forward direction, and to block in reverse direction. This principle of diode makes it work as a rectifier for a circuit to allow the current flow in one direction but to stop in the other direction. The rectifier diode is the best choice, thus the output will be DC, removing the AC components. The circuits such as half wave, full wave rectifiers are made using diode. A diode is also used as a switch. It helps faster on and off for the output that should occur in quick rate. VI characteristics of diode. A practical circuit arrangement for a p-n junction diode is shown in the following figure. An emitter is connected in series and voltmeter in parallel. Well, the supply is controlled through a variable resistor during the operation. When the diode is a forward bias condition at some particular voltage, the potential barrier gets eliminated. Such a voltage is called as a cutoff voltage or clean voltage. If the forward voltage exceeds beyond the limit, the forward current will rise up exponentially, and if this is done further, the device is damaged due to overheating. Second is resistor. What is resistor? Resist is the word which means to oppose. Resistance is the property of opposing the flow of electronics in a conductor or a semiconductor. A resistor is an electronic component which has the property of resistance. The symbol of resistor is shown. Unit of resistor. The units of resistance is ohms, which is indicated by omega. The formula for resistance is R equal to V upon I, where V is a voltage and I is a current. It would really be difficult to manufacture the resistors with each and every value. Hence, few values are chosen and the resistors of such value are only manufactured. These are called as the preferred values. In practice, the resistors with the near values are chosen to match the required application. This is how practical resistor look like. Third is resistor color coding. What is color coding? A process called color coding is used to determine the value of resistance for a resistor. A resistor is coated with 4 color bands where each color determines a particular value. The first 2 colored bands indicate the first and second digits of the value, and third color band represent the multiplier number of zeros, added number of zeros added. The fourth color band indicates the tolerance value. Tolerance is the range of value up to which a resistor can withstand without getting destroyed. This is an important factor. The 5 color band resistors are manufactured with a tolerance of 2% and 1% and also for the high accuracy resistors. In these 5 band resistors, the first 3 bands represent digits, fourth one indicates multiplier and the fifth represents tolerance. Example: determine the value of resistor with the color code yellow, blue, orange and silver. Solution: the value of yellow is 4, blue is a 6, orange is a 3, which represent multiplier, silver is 10, which is the tolerance value. Hence the value of the resistor is 46 multiplied by 10 means 46 k ohms. Fourth and last, resistors series and parallel. Resistor in series. A resistor when connected in a circuit, that connection can be either series or parallel. Resistor in series. Let us observe what happens when few resistors are connected in series. Let us consider 3 resistors with a different value as shown in the figure below. Resistance. The total resistance of circuit having a series resistor is equal to the sum of the individual resistance. That means in the above figure there are 3 resistors having the value of 1k ohms, 5k ohms and 9k ohms respectively. Total resistance value of the resistor network is R equal to R1 plus R2 plus R3, which means 1 plus 5 plus 9, 15k ohms is the total resistor, where R1 is the resistance of first resistor, R2 is the resistance of second resistor and R3 is the resistance of third resistor in the above resistor network. Voltage. The total voltage that appears across the series resistor network is the addition of voltage drop at each individual resistance. In the above figure we have 3 different resistors which have 3 different value of voltage drop at each stage. Total voltage that appears across the circuit V1 plus V2 plus V3, which means 1V plus 5V plus 9V 15 volts is the total voltage, where V is the voltage drop of first resistor, V2 is the voltage drop of second resistor and V3 is the voltage drop of third resistor in the above resistor network. Current. The total amount of current that flow through a set of resistors connected in series is the same at all the points through the resistor network. Hence, the current is the same 5 ampere when measured at the input or at any point between the resistor or even at the output. Current through the network. I equal to I1 equal to I2 equal to I3, which means that the current at all point is 5 ampere, where I1 is the current through the first resistor, I2 is the current through the second resistor, and I3 is the current through the third resistor in the above resistor network. Resistor in parallel. Let us observe what happens when few resistors are connected in parallel. Let us consider three resistors with a different value as shown in the figure below. Resistance. The total resistance of a circuit having a parallel resistor is calculated differently from the series resistor network method. Here the reciprocal R divide R1 divide R. Value of individual resistance are added with the inverse of algebraic sum to get the total resistance value. The total resistance value of the resistor network is 1R equal to 1R1 plus 1R2 plus 1R3, where R1 is the resistance of first resistor, R2 is the resistance of second resistor, and R3 is the resistance of third resistor in the above resistor network. For example, if the resistance value of the previous example are considered, which means R1 1k ohms, R2 5k ohms, and R3 9k ohms, the total resistance of parallel resistor network will be R11 plus 15 plus 19, 46.2 ohms. From the method we have calculating parallel resistance, we can derive a simple equation for two resistor parallel network. It is R equal to 1 multiply R2 R1 plus R2 R. Resistance. The total resistance value of the resistor network is 1R equal to 1R1 plus 1R2 plus 1R3, where R1 is the resistance of first resistor, R2 is the resistance of second resistor, and R3 is resistance of third resistor in the above resistor network. Voltage. The total voltage that appears across a parallel resistor network is same as the voltage drop at each individual resistance. The voltage that appears across the circuit V equal to V1 equal to V2 equal to V3, where V1 is the voltage drop of first resistor, V2 is the voltage drop of second resistor, and V3 is the voltage drop of third resistor in the above resistor network. Hence, the voltage is the same at the all point of a parallel resistor network. Current. The total amount of current entering a parallel resistor network is the sum of all individual current flowing in all the parallel branches. The resistance value of each branch determines the value of current that flow through it. The total current through the network is I equal to I1 plus I2 plus I3, where I1 is the current through the first resistor, I2 is the current through the second resistor, and I3 is the current through the third resistor in the above resistor network. Hence, the sum of individual currents in the different branches obtain the total current in parallel resistor network. A resistor is particularly used as a load in the output of many circuits if all the resistive load is not used. A resistor is placed before a load. Resistor is usually a basic component in any circuit.